Similarity, Part 8. We've learned that with similar triangles, or similar figures in general, that angles are going to stay the same and that there's a relationship between our side lengths. That relationship we call either a scale factor, if we're comparing one triangle to another, or we call it equivalent ratios, if we're comparing one side length of a triangle to another side length of that same triangle. We can take this concept and apply it to some real world problems. For instance, let's say that you're a hiker and you're hiking in Yosemite National Park and you're going to try to figure out the height of Half Dome, how far you're going to have to climb from the valley all the way up to the peak. Well, you can do this using simple shadows. What we have pictured here is a hiker with a 7-foot hiking pole, and we have Half Dome itself. Now I've put some labels on the picture, and those labels are dealing with specific things. First off, the 2 feet. 2 feet, notice, is on the ground. Well, what that is it's the shadow length of our hiking stick. You can see our sun taking down rays at a certain angle, and that angle is forcing a shadow on our person and on our stick. In this case, it's 2 feet. That same sun is casting another shadow, this time off of Half Dome, and it's creating a shadow for him too. This time, we can take a measurement of 1,000 feet. Now, both of these things are things that we can measure because, well, they're on the ground. The stick is something that's fairly small. The thing that we can't measure is the height of Half Dome. But if we use the same properties that we learned with similar triangles, with this example, we should be able to do it because there's a relationship between these triangles. There's our big triangle, and there's our small triangle. There's a relationship not only between our scale factors, but also between our ratios. And we can use either of them to figure out the height of Half Dome, at least approximately. Let's focus first on scale factors. If we focus on the small base compared to the large base, we go from 2 to 1,000. That's a scale factor of 500. That means everything on this triangle is going to be 500 times larger than the things on this triangle, including the height. So our height of 7 feet times 500 is going to give us the height of Half Dome, at least approximately. We get an answer of about 3,500 feet. We can do the same type of figuring out of 3,500 feet by doing equivalent ratios. We can compare 2 feet with 7 feet. How do you get from 2 to 7? Well, it's a multiplication, again, of 3.5. Now in this case, we're comparing the base to the height. So the height is 3.5 times larger than our base. That's true on a small triangle, that's true on our large triangle. So we could take our base of our large triangle, multiply it by 3.5, and we're going to get the same answer of 3,500 feet.